There we go. Okay. Oh, and some more people showed up. Perfect. So if you're just joining us, this is going to be an introduction to Shader Graph, which is a visual programming system for creating shaders on your computer. There's a lot of ways to make shaders. You don't necessarily have to do them in Unity the way that I'm going to show you today. Uh, and over the span of this hour or so, you're going to better understand how shaders work. You're going to understand how that programming language kind of functions and how it actually creates some sort of visual output that creates imagery that you want to see, not only on our computer screens in general, but also almost every sort of 3D graphical effect uses shaders in some way. The simulation behind me is actually also done in shaders, although not the ones that I'm going to be showing you today. So before we actually get started, if you want to follow along at home, I'm going to very quickly tell you to download and open Unity. And to do that, I'm going to share my screen for it very quickly. And if you have or don't have Unity hubs, that's fine. So in Unity, this is important. When you make a new project, just make a new one and don't open a default 3D. You're going to open a universal render pipeline project or an HDRP project, this high definition render pipeline. It's important that you open up one of these and do this now if you plan on following along later, because this takes some time. I'm not going to do this because I have a project already set up, but make sure that you select the universal render pipeline and then hit create. And that should buy us some time for me to actually talk about what shaders are and how they actually function. So that out of the way, let's talk again about shaders. So you might be generally familiar with them as like something you've heard about or something you might have worked with. They're programs that run on processors on your computer in the most basic sense. And while that's true of basically all programs that you write on your computer, it's particularly important to remember this for shaders, because shaders are small and tiny, and they're also very dumb. But they have the advantage of working completely in parallel, which is not something that most standard programming languages let you have access to without accessing things like threading or a lot of other low-level functionality. They are by nature parallel. And what does that mean really for us to work in parallel? Well, the common example is like if you wanted to dig a hole, and you think about how digging a hole works, you're limited by literally how deep you are at any given moment. So the fastest way to dig a deeper hole is to learn to dig faster. And so this is like when we talk about processing speeds and like the amount of gigahertz that your computer is capable of processing. Those are the types of speed that we're talking about. Those are allowing our programs to basically run faster. But in reality, if we're going to try and code some sort of parallel system, then what we're doing is we're coding one program that is given to a series of parallel units. And so in that hole digging example, if I wanted to dig 10 holes, I'm limited by how many people I have, not by how fast I'm going to be digging. So I can have a bunch of people side by side with one another, like say myself and 10 others, and we're all going to try and dig a hole. And essentially, that's it. You give one set of instructions to a bunch of hole digging people, and then they execute those instructions sort of regardless of where they are relative to one another. And that's the high level of shaders. But what does that actually mean for when I'm trying to code a shader myself, and what I'm going to do to try and work with it? And if you're just joining us, I told some people to try and open up Unity now, and if you can, open it up to a universal render pipeline project, so that you can have time for it to import everything and let you create everything that you're actually going to need, while I kind of go over some of the basic introduction to like what shaders actually do. So back to that thing about what does that mean for us as shaders? Well, it turns out that the computer screen is the perfect place for having parallel computing because all of your individual pixels on a screen actually function as if they are individual wholes. Um, on this behind me, right, this is like a very exaggerated version of what you might expect out of a computer screen. I have individual squares that are all going to be processing themselves in some way uh, to create some sort of image. And this is somewhat of a challenge to work with because any one of these things only knows who they are, essentially. This pixel only knows its pixel coordinate, the other pixel only knows that pixel coordinate. And so they can't actually cooperate with one another to generate the image. They can only execute the same exact instruction. This makes it a little harder to actually reason about what's going on inside of our shaders sometimes. Um, oops. Okay, I hope I didn't lose connection too badly there. Uh, because if you think about drawing, if you're trying to draw in something like processing, or if you're trying to draw in like a Adobe Photoshop or Paint, you take, or physically, literally, you take your pen and you put it to the paper and you actually start drawing it out. You have a pen, you have a literal object that you're taking and you're moving. In the case of a shader, we're taking essentially the canvas and we're telling every part of the canvas whether or not it should be drawn upon, and then just saying, go figure it out yourself. And that is what we're going to try and do here. And so shader graph is a way of actually getting into some of that type of program. So I'm going to now set into the Unity shader graph environment. That off. Let's see here. Here we are. And turn this off. Okay. So you're going to want to full screen this video, and I will try my best to kind of like gesture at what's going on and kind of show you. So if you've already created your Unity scene, and I'm not going to use this one, if you have just opened up a universal pipeline, people are want to modules in time. The audio is cut. Okay, you can hear. Okay. So all I was saying earlier was that so go ahead and tell me if you can, if you're in this scene. This should basically be what you see if you're in Unity right now, and you opened up that default universal render pipeline project, or if you opened up an HDR one, go ahead and let me know. That way, if you're following along, I can modulate towards what we have. But this is the basics of getting into Unity shader graph, which is a little awkward, I will admit. Did anyone open actually Unity to do this? Cool. Are you still importing, perhaps? Okay. Okay, cool. So if you're already in this scene, that's great. We're gonna literally just get rid of everything, or open up a new scene, either way. So let's see. Actually, going to change this very quickly. Here we are. So I'm just going to take the post-process volume and example assets and delete those. I don't want them. And that leaves me with this empty scene, basically. And to get yourself set up, you're going to come here to the left, create an object, and create a plane. I'm going to take the camera, I'm going to reset its position. And I'm going to come to the plane, reset its position as well. And basically, this is just a setup to get the camera pointing at it. Some of you may already know how to do this. I'm not going to spend too long on it because it's a little cumbersome to have to also explain Unity for that, but that's it, basically. And so you can see that I have a scene set up with the camera, which is what I actually need. Cool. So this gets us ready to basically have nothing else interfering with what we want to do, which is play with shader graph. And so in your project hierarchy, mine is over here at the bottom left, and it may not look like that for you. It might be a set of folders, perhaps. Let's see. I forget how to show it differently. But you're going to come into here, and you're going to click this plus icon. You're going to come all the way to the top where it says shader, and you're going to click on unlit graph. I realize it does not show you that on the stream, so I'm going to change this real quickly. And this should be a little bit better. If you come here to clicking that plus sign, bottom left, and you should be able to add this unlit graph, and that will create this new shader graph for you to manipulate. Don't put it in the settings folder. I'm just going to call this unlit. And then I'm going to move that out so it's in a place that's a little bit more obvious for me to work with. And then I'm just going to click on that unlit. And this is shader graph now. You're now inside of it. But the shader itself is only one half of the equation. What we actually want to do is also create a material for it to render, because otherwise, whatever I put on this shader graph does not actually create anything for me to work with. So I'm going to come back out here to the project, and I'm going to create a material. And you should have shader graph unlit material. If you don't, click on the shader graph inside your project, down here at the bottom left of my screen. Right-click it, and literally go to create and create material from it. And that should definitely create the material from that shader graph. That's a really important thing to get these working. Otherwise, you won't be able to, well, there are ways of setting materials to shader graphs, but they are a little finicky, and I don't want you to have to worry about that. And so that should give you a material that you're working with. So if you come back to the scene view, here we are. You should be able to take this unlit material, drag it directly onto that plane, and that will change it to use the shader graph that we just used to create the material for that plane. And so now all of those little shader computers are working on this piece of material. Okay? Hope that's simple enough so far. And did everybody follow up to that point? I just want to make sure. Sure. Can I reiterate the material part? So because of Unity's quirks, right, we have to actually create a material before any sort of shader is actually applied to objects in a 3D scene. So you're going to come to your unlit material, sorry, your unlit shader graph, the thing that you made first, you're going to right click on that. You're going to create, and you're going to create a material, and that should create a material from uh, that shader graph, which is what you will then use, this thing right here. And you can see here in the name, it says that it's using the shader graph unlit that I just created at the top right. And then you'll take that material and you'll drag it on top of the thing that you want to be colored with that material. Uh, Materials are a sort of Unity specific way, not Unity specific, but a 3D rendering way of looking at basically shader textures that are created. And so that applies the material to that shader and that material to the actual object that we want colored. Because you could hypothetically, not hypothetically, I'm going to do it. You can create a sphere, right? And so here's a sphere for me. This is using the wrong material. I can take that unlit material and put it right on top, and now it's colored the same way as. If you need a shader editor, you have possibly created the wrong thing. When you create, you want to make sure that you're creating a unlit graph, not that you're creating a shader. So I think you can see that in my window. So if you come to shader, there are these things up here: the surface shader, the unlit shader, the image effect, and the compute shader, and the ray tracing shader. And you want to ignore those and come to the unlit graph. Yeah. Annoying thing to note: those things don't actually work in Universal Render Pipeline, so that is a separate problem for Unity to deal with. Anyway, okay, so now we have the basics of our scene set up, and we have a graph, a material, an object with that material, and we have something looking at it. And so now let's actually look at the graph that we want to play with. This is where all of our actual quote-unquote magic will happen. And so what's in shader graph? The interface is pretty simple. You probably have this thing on the left available to you, which is a blackboard of a bunch of properties. We're not going to worry about that for now. So shader graph is a node-based programming interface, and if you're familiar with those, this will be very natural to you. Node-based programming interfaces essentially turn variables and functions into nodes that you hook up and attach to one another, and that will create the result that you want. And so everything is done as a form of transformations, and then there's a master node, usually the end node, at the very end that actually holds all the outputs that you want to cover. In this case, we have this unlit master node, which has vertex position, vertex normal, vertex tangent, color, alpha, and an alpha clip threshold. We can ignore the first three for the purposes of this this workshop. I'm going to just show you a very basic thing that we can do. So right now, and also we have this preview over here on the right, but you tend not to need that. But we know, for instance, that our materials out there in the scene are that gray color, which isn't very appealing. So we're going to do things like just make a color. And to do that, you can literally just come here and hit, I believe, space, or right click, create node. And we're going to get a color node. So type in color. This is, again, part of the interface quirks, is that you get the opportunity to look at all the different things that shader graph has made available to you. In this case, we're using color, which is very nice. And I'm going to hook that up by clicking the output and connecting color. And that should immediately change it. Then if I want to see this represented, I need to come up here to the top left and click Save Asset. And having done that, now I can come to the scene and see that my object is actually now colored in this black color. Great. But that's very boring. And if I just want to color something a single color, I probably wouldn't need to learn how to work with shaders. The interesting thing, of course, comes when we start manipulating those colors in ways that 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 allow us to be responsive because it creates very quick real-time graphics for things. So we want to have sort of manipulated color. Remember earlier I said that every single position on that shader has its own little computer running on it, and it knows its position. And we can actually access that position by creating a node and getting what's called the UV node. And the UV node is a node that takes the coordinate of that actual little computer and turns it into a color. It's not really being turned into a color. It's taken between 0 and 1 and then converted into something that is a vector form. And like any other color that has 3 digits, right? RGB is just 3 numbers. The vector form of that color can be of the coordinate, sorry, can be represented as a color. And so here you can see that in this red and green version of the RGB. And if all I do is connect that UV, which is just, again, the coordinate positions to that color node, here I can have access to all of the nice colors presented in the actual scene. Great. That's step 1. Well, now I want to manipulate that color a little bit further. So I'm going to take that and I'm actually going to split it, which is another built-in node. And another thing that you can do inside Shader Graph is literally click this output into empty space and will automatically ask you if you want to create a new node, which is great. And then I'm going to create a new one and I'm going to go to split. And that lets me split it out into multiple different shades rather. And I can just come out here and see what exactly each of these values are. So this is the red value. We look at this RGB. So now I can see that the red value, this X value of each of the positions, increases as we go along the edge of this position, which makes sense, right? We start at 0, 0, and we are moving towards the right to get the value that we actually want. I'm actually going to switch to this. It's now a little bit more important that you... Yeah, so if you can, make my video full screen within Zoom, and there you'll be able to actually see what's going on. There we go. I've spotlighted it. Okay. I'm going to very quickly grab a cheat sheet for myself. Or not. There we go. Okay, ignoring that for now. So what we can actually do now that we have all of these colors and we can technically split them is that we can recombine them. So I'm going to drag this out again. I'm going to combine each one as a different value in a different vector. And so if I take that red value, which used to go, as you can see down here, left to right, now I can make it go in a different direction. And here you can see I've transformed that color from one thing to the other. And that's also still, that's not that interesting, right? Like that's fine. We've still just been manipulating color in sort of an interesting way. But we can still do more. And sure enough, we are going to. So we want to have some sort of like movement of this color. And to do that, what we're going to start adding is what's called time node. So I'm going to hit space and add time. And that creates this node here, which is the time node. And this is going to be added to the other positions in order to actually create a color. Just going to make sure I recreate this faithfully, otherwise I'd be a little worried. So I'm just going to combine it to the RGB value of that whole thing. And then now, because it's just increasing over time, I'm going to do some more math to it, essentially, and add the cosine function. And that produces this shape. I'm going to add that to the color node. Oops. Now if I save this asset, now I have this animated material. And I've created that based on something that essentially just responds to time. It's going to do this regardless. I don't have to tell it to do anything else besides exist, and all of the different pixels on it are going to essentially update themselves as they need to for producing a color, right? And that's the very, very basics of how this works. It's also nice sometimes to just make a small offset, which I'm going to do. So I'm going to drag that out again and just simply add this to it, 024. Put that over here. And now we see actually that every single one of the images and colors actually cycles a little bit differently. And you get this color sweep effect. So there's a lot of things that you can do out of this. It's impossible for me to go over all of the different nodes that are available within Shader Graph. There are a ton. Oh, that's why this isn't working. I'm going to connect red to the blue channel. But notice also that I'm not really using any specific color in this sequence. Like, the color is a consequence of the fact that every single piece of the shader has some sort of coordinate. And that coordinate can be manipulated and transformed into color. Let's see, what other things can be done? But from here you have the basics, and I think, you know, that's just one aspect of it. If you want to get deeper into Shader Graph, I'm going to switch the scene that I'm in order to look at some other examples that I've made, and I will walk you through them so that you can understand how to at least convert the image into something that is like maybe cubic or like a repeated tile effect. And close this tab. So here at the behest of someone else who's in this Zoom call, I made this shader, which has some nice little effects going on. Everything's sort of tiled together and independently drawing at any moment. And what does this actually look like on the other side? Well, you can come here to the unlit graph, which will take a second to load. What is happening? Okay. Jay, I'll answer your question very briefly in a short second. So this is the graph that produces that pattern there at the bottom right. And as you can see, it's quite big. It probably doesn't need to be as big as it is, but it just happens to be because of the way it came together. But this is like the scale of what can be done within Shader Graph. It can get very large. As for Jay's question, which is what is happening if the combine is responding towards time, but your main preview is not and is not updated on the unlit material component? Well, let's see. So I don't know exactly what your setup is on the cosine.
Yeah, what? Oh, I think it may be helpful to see what cosine is connected to, because I may be
Sure.
missing that
Ah,
part.
cosine is connected to this.
Unit
The
unlit
this is
master.
the unlit master, which is your output node.
Um, oh,
And
okay.
Sarah,
Thank you.
yes, it will be uploaded, so you will be able to rewatch this if you need to. And there's a lot in here. I know I'm covering a lot of different things. Yeah, and so hopefully, Jay, that helps out. Remember that everything needs to actually connect to this final node, otherwise you don't get any output, and everything is sort of like thrown away if it's not connected. That's definitely the case for this unlit graph where I produce this sort of ice cream pattern because I have a bunch of nodes over here that aren't being used and a set of nodes down here that are completely ignored. But as long as the output actually reaches this final node, this unlit master, you will actually get the output to be shown on the objects themselves. And so this is obviously a little bit too big for me to walk through step by step exactly what happened. So instead, I wanted to look at this square graph, which I think is a very simple version of what you might use in other effects, essentially. For instance, what's going on here is a way of scaling out the space. So we know from the basic UVs that you get a 0 to 1 on both axes here. So y goes in 0 to 1 and x goes in 0 to 1. Uh, you can use that to your advantage and create colors, as we did in the previous unlit graph, right? And we can just move them around to create a new color. Um, that's one way of using them. Another way is actually to use them to create specific patterns and repeating patterns. And so here I have this multiply, which multiplies it by 10. It does not need to multiply it by 2. And then I put it through two other functions. One is called floor, and the other is called fraction. Fraction basically cuts off the whole number part of it and just gives you the fractional part. So I get this looping pattern of 0 to 1, 0 to 1, 0 to 1, which is what produces this smaller pattern, which looks like this one over here, but of course reduced down to the scale of 10. In the floor, I just take the integer part, and that's all. And so I've basically separated any single part's integer whole number part from its fractional part. And then I take the fractional part because anything above 1 is ignored essentially by the shader, and I modulus it by 2 to give it a sort of a repeating value. So I'm just checking if it's odd or even at any given moment. And so if it's odd in one direction or even in the other, it will produce this particular color. And that mixes itself based on what it is. So for instance, it's 0 at first in both dimensions, then it's 1, then it's even, or sorry, it's odd, then even, odd, then even, odd, then even. That's what's producing this red and black pattern. Going up is the same thing. Odd, even, odd, even, odd, even produces this green pattern. And then there just happen to be mixed in some cases, right? Because this one here, this yellow, is both odd and even, or both of them are even, so they're both 1, and so you get red and green, and you mix into this yellow. And then you get this nice ginghamy pattern, which is nice. But we can combine that with a lot of other stuff, because if you think about what this fractional part is, it's the same as if I processed anything out of the UV. So if I come over here and take that whole unlit node, unlit stuff that I was doing before, I'm just going to come to this unlit node, and you don't have to exactly follow along for this part. I am going a little quickly. I'm just going to take this. I'm going to copy all those nodes that I had, come back to that graph. I'm going to paste them here, move them around a little so that they're not overlapping entirely. And into the split node, I'm actually going to feed it this fraction. And what does that do for me? Well, you can actually see that it recreates that pattern over and over again. And now you can actually see it happen down here. There's this multi-gradient pattern now. And I'm going to now apply the color to the material, and we get this, which I think is pretty cool looking in one way. But I think you can still do something else. Remember that I have these whole number parts, and those happen to be useful for creating some sort of offset, the same way that I created the offset here. So what I'm going to do is I'm going to drag out another add. Oops. Take this, add. Combine that together. And then put that into the cosine. And now you can get this alternating gradient effect just by using those same values that you had before. So this is like, these are still slightly more advanced. Like, not all of these are very, very basic. If you wanted to create some extremely simple ones, all you have to do is start with color, right? I'm going to come back to this unlit graph over here. Messing with positions and stuff, I think those are the benefits of shader graph. Being able to mess around with, say, like warped colors and positions like this are also one of the benefits of shader graph. Sorry, of shaders in general. Shader graph helps you visualize what's going on. But if these are getting to be interesting for you, I highly recommend just playing around with the types of things that you have available to you. Because if I come here to the unlit, I'm going to disconnect it from the unlit master. I'm going to make an entirely new shader out of it. I'm going to delete this, hide these. Don't need them. Let's just come over here and make something entirely new using a different set of nodes. So I'm going to hit space. You can't see this right now, but I'm going to create a new one. I'm going to go to something called procedural. I'm going to get shape, and I'm going to get the ellipse. And you can literally just hit space, ellipse, and you'll get the ellipse. And this lets me actually put a circle on top of the image. And these are using the wrong materials. So I'm going to change that. There we go. So there's the circle. And the exact map of how this circle works is sort of beyond the scope of what I want to teach you, but at least want to show you a little bit more about what shader graph provides you, because it's quite useful. Another thing that we can use node-wise is something called noise. You can get gradient noise like this, which is great. You can plug that in and get something a little bit strange, right? Like, what does it mean to throw a gradient into an ellipse? That's maybe not quite what we want to do. But what you could do is multiply the two together. And now you have something that resembles essentially an alpha mix, right? Those of you who are used to things like Photoshop, that's probably very familiar to you. And you can also scroll this around. Again, using just time. Notice here in the gradient noise that it takes a UV position, which is something we have access to, right? I'm going to take UV, and I'm going to use what's called tiling and offset. And I'm going to hook that up with the UV for the noise. And then in the offset, I'm just going to give it a direction, but it turns out I can just use time for that. So time will now scroll, making this look like that, giving me, hopefully, oh, it's not connected, my bad. And remember, always come up here to save asset on the top left, otherwise it's not going to actually save and propagate to your scene. I did that, now I'm going to come here, and there we go. Now I have my animated thing along with it. But that's still kind of weird, right? Like, it's just sort of an alpha mask. So what if I did a mixture of the two values? And that's what I'm going to try and do next, which means I'm going to drag this out. And mixing stuff is interpolation, which you might be familiar with. I think this should work. Crap, I can't remember it off the top of my head right now. But it's possible essentially to blur the edges of this circle. Forgive me, I can't remember it off the top of my head, and I don't want to entirely drag on. But I hope that has given people at least a decent sense of like what's going on, and if you're following along with these, that you kind of understand what's going on, not only programmatically but also graphically, essentially what's happening. Yeah, are there questions that I can answer for people? Things that they would like to look at? You can apply this to meshes. So the question is, can I apply this to meshes? And the answer is yes. One thing I did not touch here was vertex position. That was just sort of for specific reasons, being way more complicated than introduction can really cover. You can manipulate, as long as you have the vertices of your mesh, you can totally manipulate them. In shader graph, you can actually just come to create node, and you can get vertex positions. So you actually can get the position of fragments and vertices. You can transform their space, and you can manipulate those as well. So the applications for shaders are really wide. Jay asks, what are the applications for shaders? Basically, every single 3D graphical application that you have ever interfaced with is probably using shaders underneath it. At the same time, your Photoshop, Illustrator, After Effects, all of these things that are in the Adobe suite, any sort of image manipulation is actually very likely built using shaders. If I come here to this unlit graph that I have, creating this effect here, what I've done here is essentially use multiple image layering effects as well as image masking effects. For example, here, although it's not perfectly obvious what's going on, what I've done is this right here, this measurement. So to go from this image here on the left to this one here on the right, I need to be able to add color to it, but I need to be able to add color in a way that isn't fill the whole thing, right? Because I'm working with the shader program. I'm not working with something like Adobe. And so what I do is I take the value of any given pixel, which is the length of it, determine if it's over 0 in this step function, and that creates a mask, because if it's under 0, it will be 1, and if it's over 0, it will be 0. And so that creates this white area that I then multiply with the color. So if you've ever heard of like Photoshop multiply, this is what's happening. You take the color of the previous one and you multiply it against the new color, and then I add that back into the original image. For a preview purpose, I'm going to come here, open this up. It's going to look exactly the same, but that's because this color, let me make this more obvious. I'm going to take this color. I do like. I'm gonna replace it with. Had another color I wanted to replace it with, but that's okay. Anyway, let's replace it with this blue, which is very ugly, or something more orangey, perhaps. Or I'm bad at color theory, but you can actually see that color change, um, but only affecting certain parts of it. There are a lot of so these are the sort of image purposes of this. Um, the other major reason that shaders are popular now is actually in machine learning, where essentially this vector information, this color information that you've probably seen used in uh, computer vision or um, basically feature recognition, is done by taking one of those images, processing it through a shader, um, usually a little higher level than that, but at the core basics of it, it's a shader program that will then take every pixel of that, convert it into something else, and then continue that conversion down the line. Those sort of like layers of machine learning that people often talk about, of like how many features that they have to go through. That's essentially what's happening. Is that a shader is running through that. Yeah, those. So there's tons of different applications for them because they are so fast. They are for parallel computing. Uh, you can come up with a lot of different ways to use them. But just know that the information that you're using has to be some sort of numerical stuff, although that's changing with time. Any other questions? I hope that was a helpful answer, TJ. There's definitely a ton. I don't know them all. November projects for Blender. Yes, Sarah. Sarah says that I was gonna the node setup here reminds a lot of the node projects for Blender or Filter Forge, and it's the same kind of principle. Like it totally is. There are, and I think someone from our I think it was Anna in our program was actually working on a some language processing stuff for nodes, and I think that like learning this like you can tell that there's a lot of like cruft going on here. Like you wouldn't necessarily want to code like this long term. Uh, if I come to this square graph, this is actually way easier to program in like actual coding terms because it's shorter. But visually, it helps you understand and think about what's actually going on here. Yeah, I think it's really great to be able to work with these. And like beyond this, like so for an example, this is like I'll quickly show this because I think it's nifty. Uh, Close that out. Separately from this, so like this is an example of the things that go beyond what we were talking about with just image processing. Is that you can start processing arbitrary data, uh, and if you wanted to go down this route, you can. So what I'm about to show you is like bird simulations. So particle simulations are often done with shaders because if you have thousands upon thousands of shaders, it's not that you need a very, very fast computer to run through 7,000 of them. It's that you need 7,000 small computers to run simple simulation information. I want to show this to you, so it's loading. And so this is an example of one of those things. It renders out visual information, but it's actually processing something different on the inside. If it will, come on. apologies. It's not working very well. Unity and streaming don't really go well for me. There we go. There's some of it. Give it a second. Yeah, it's not liking how I have to stream this right now. So I'm going to reduce the count. Apologies, it's not working. But you can kind of see this is a bunch of different particles that have their own different rules that have to interact with one another. Um, and it's running on GPU. It's running with shaders. This is not written in nodes. So the question was, can I see the node for this? This is more like the new application of shaders, which is like writing compute stuff. Because this doesn't start with image data. It outputs image data, but it actually doesn't start with image data. There's no nodes for this. It might be happening within the next year that nodes would exist, but as is, it cannot be written that way. So that's one of the limitations of the node system is right now a lot of shader nodes are purely for image effects, so you don't really get as many what's the word I'm looking for? You are still limited somewhat to like image effects with basic shaders. I think this one should work better. I think this is a Conway Game of Life, which is also so like what's going on here is that it looks like there's a square being drawn, but in reality it's a bunch of different little particles that are going in that shape and moving around, and this diffusion sort of occurs as a result of that process. So yeah, thanks for joining everyone. I hope that was enough to sort of whet your appetite. There's a lot to do in shaders. There's no way I could cover even half of everything that exists in that space. But yeah, thanks for joining. Feel free to look these up. I have a ton of resources. If you need to know them, you can ask me. Um, I have tried to learn a lot about them, and yeah, have fun. They're cool. I like them a lot. And this recording will be up later. So bye everyone.